So in this video, we're going to do a little bit more in depth with our complex numbers. We've already talked about how when you take the square root of a negative number, you put the I on the outside of the radical, but we're going to talk about kind of where that comes from and a little bit more with them. So the first thing that's important is you should know that I to the first power, oops, where's my pencil? There we go. I to the first power is just I. I squared is -1, and that's how when we take the square root of a negative number, we just put the I on the outside. I to the third, you don't necessarily have to memorize. If you remember these two, you can get I to the third if you don't remember it. So I to the third is the same thing as I squared times I to the first, because when you multiply, you add the exponents. Well, I squared, that was just -1, and I to the first, that was just I. So I to the third is -I. And then I to the fourth, that's really the same thing as I squared times I squared. And I squared, that's -1. I squared is -1. So I to the fourth is just 1. Now, in order to simplify anything that's a higher exponent, you just have to remember how to divide by 4 and use your remainders. So the first thing I'm going to do is I'm going to take my exponent and I'm going to divide it by 4. So 4 goes into 9 2 times. Bring down my 7. And then 4 goes into 16 4 times. And we have a remainder of 1. So out of all this, the only thing we actually care about is the remainder of 1. The rest of this doesn't matter at all towards our problem. We just care that it's the remainder of 1. So what this means is that I to the 97th is really just the same thing as I to the first. Whatever our remainder is our new exponent, which means I to the 97th is really just I. Now, if you need some more examples to kind of understand what's going on, if we take I to the, let's say the 13th, this is really the same thing as multiplying I to the fourth times I to the fourth times I to the fourth times I to the first. So when we add all these up, 4 plus 4 plus 4 plus 1 is 13. So this is the same. And if you look at this, I to the fourth is 1, I to the fourth is 1, I to the fourth is 1, and I to the first is just I. So that's how we have just I. And you could have gotten that if you do 13 divided by 4, you have a remainder of 1, so that's just I to the first. If I were to give you I to the 19th, when you divide 19 by 4, you get a remainder of 3. So I to the 19th is the same thing as I to the third, and I to the third is the same thing as -I. So really, most of the time, kids just make this more complicated than it is. All you have to do is divide by 4. And you'll know your i's are fully simplified when you have no exponents at all on your i's. So adding and subtracting is really simple. You kind of just pretend like the I is any old regular variable. So you're going to combine like terms. So the -6 and the 6 can combine, and that's going to give me 0. Then you have -2i plus -5i, and that's going to give you -7i. And then just get rid of the 0 because you don't need it. Okay? Over here, the hardest thing is that you have to remember you distribute the negative to both of these. So you have -5 minus 4. That's going to give us our -9. Then you have +3i minus -5i. So 3i minus a -5i changes to a positive. So you have 3i plus 5i, which is going to give us a +8i. So that's all there is to adding and subtracting. Just combine your like terms. So one important thing to know about your complex numbers, and it's really going to come into play when you're in your higher level engineering classes, is the conjugate. So a plus bi is the standard form for our complex numbers. Okay, so we always want the number with only the real number first, and then we want the imaginary number. The conjugate is a minus bi. So anytime it asks for the conjugate, all you're going to do is take the sign in the middle and change that. Okay? But when we multiply, it's just like multiplying any binomials. If you want to use your box to multiply it, you can, but I'm just going to FOIL it out. So FOIL, I'm going to do my first. 5 times negative 3 is negative 15. I'm going to do my lasts. 5 times negative 7i is negative 35i. I'm going to do my inners. 5i times negative 3 is negative 15i. And then I'm going to do my last. 5i times negative 7i is negative 35i squared. And then I just need to simplify this. So the negative 15 is going to come down. In the middle, your middle terms are going to simplify to negative 50i minus 35. Well, I squared is really just negative 1. So if I carry all this down, negative 35 times negative 1 is a positive 35. So you end up with 20 minus 50i. So again, we know that it's fully simplified here because none of my i's have any exponents. If you notice on example 2, you're just multiplying the conjugates. Okay, so 3 plus 2i, 3 minus 2i. I'm going to do my FOIL again. So my first, 3 times 3 is a positive 9. My lasts, 3 times negative 2i is negative 6i. My inners, 2i times 3i is a positive 6i. And then 2i times negative 2i is going to be negative 4i squared. And if you notice, these two terms in the middle are going to cancel out. So you get 9 minus 4, and then I squared is really just negative 1. So you have 9 plus 4, which is just 13. So this fact is really important for when we're simplifying our imaginary numbers. And if you notice up here, I had put multiplying by the conjugate gets rid of I. So every time you multiply by the conjugate, you should get rid of your I. And that just goes back to when we dealt with our difference of squares. If you remember, our middle term always disappeared. So if you look in this line right here, I have my 9. It did not change colors. There we go. I have 9 minus 4i squared. So 9 is a perfect square, 4i squared is a perfect square. So 9 minus 4i squared is difference of squares. So that's why you get 3 plus 2i and 3 minus 2i. So dividing is where it gets fun. When you divide, you cannot leave I in the denominator at all. Okay? So on this one, when we just have a monomial, we're going to multiply the top and the bottom by I. Okay? And since it's I over I, it's really the same thing as multiplying by 1, which is why we're allowed to do it. So when we multiply the top and the bottom by 1, I get 4i plus I squared over 8i squared. And now I just need to simplify some stuff. So 4i is going to stay the same, but I squared is negative 1. Same thing on the bottom. Our I squared is really just negative 1. And when I do this, I'm going to make sure the top is in standard form. So I'm going to flip it around, and I have negative 1 plus 4i over negative 8. So now there's two ways they could give you the answer. More often than not, it's going to be written like this. But occasionally, they'll take the 8 and divide it into the 1 and the 4. So negative 1 over negative 8 is just 1/8. And when I simplify 4i over negative 8, I get minus 1/2 I. I would say more often than not, leave it like this. The only time I would divide the 8 out is if it could go into both and completely get rid of your fractions. But occasionally they will leave it like this. Now on this problem, if I just multiplied the top and bottom by I would still have an I in the bottom with the 4. So what I'm going to do is I'm going to multiply by the conjugate. So the conjugate of 4 plus I is just 4 minus I. So multiply by the top and bottom. And I'm going to make sure I do my distribution. So 8i times 4 is 32i. 8i times negative I is minus 8i squared. And then on the bottom, you can multiply it all the way out. It's 16 minus 4i plus 4i minus I squared. And if you look, our middle term should cancel out. Minus 4i and plus 4i, they do cancel out. So if we keep going through and simplifying this, we're going to have 32i minus 8 times negative 1 over 16 minus negative 1. So when I rewrite the top, I am going to switch the 8 in front so it's in standard form. So negative 8 times negative 1 is a positive 8. So 8 plus 32i over 16 minus negative 1 is going to give me 17. And there is your final answer. Again, you could break this up, but more often than not, they're going to leave it like this since it's going to definitely have the same denominator. So you have a few practice problems. I've put the answers on the screen for you already. The one thing I would do is I would definitely simplify my i's before I do anything else. Okay? So make sure you go all the way down to where your i's don't have any exponents at all before you start simplifying, and you should be good. Good luck!